So our main focus of research is looking at particles in the air, and specifically looking at different chemicals that are in those particles that humans can be exposed to. So the wildfires from Canada have been an interesting opportunity for us because we've been involved in a project out in the Pacific Northwest looking at wildfire smoke, but we never imagined being able to capture wildfire smoke here in Rhode Island. So over the past couple of days, we've been collecting samples to be able to look at the wildfire smoke that's been impacting the Northeast in addition to the wildfire smoke that's out in the Pacific Northwest. One of the things that I love about the work that we do is that it is so relevant to our everyday lives. And so students are being exposed to these concepts prior to going to a graduate program. Particulate matter is dangerous at these levels for humans to be breathing in, especially if they have pre-existing respiratory conditions like asthma or COPD, or especially for young children. But in addition to just the particulate matter itself being dangerous, the chemicals that we're analyzing for are known to have adverse effects on human health, but it takes a while for those adverse effects to show up, years, decades down the line. So better understanding those exposures in addition to the immediate exposures that are happening during events like this is what we're trying to understand. So the process for sampling the particles that are in the air starts with taking a sample of those particles on a filter. So the way this sampler works is you load the filter into the cartridge, and then the pump works sort of like your vacuum cleaner, where instead of having an opening where it goes into a bag, you have a filter at the start of the vacuum cleaner, so all of the dust and particles that are being pulled in by that motor are going to get trapped on the filter to start with. Once we run that sampler for about 24 hours, we can unload the filter, and then we can run it through our extraction technique using pressurized liquid extraction. In order to perform the pressurized liquid extraction, we have to assemble cells that are capable of having high temperature and high pressures within them. So we assemble these stainless steel cells that we put our samples into to be able to do the extraction process. Then we can concentrate those samples and run them on the GCMS and get our final numbers of the concentrations of different chemicals that are present in the particles.